Good morning. Today we're going to be covering 6.2, section 6.2 in our text entitled Multiplying and Dividing Rational Expressions. As we saw from our last video lecture, rational expressions are ratios of polynomials. And fractions are, of course, also rational expressions. And we know how to multiply and divide fractions. We covered that in Chapter 1. If I'm asking you to multiply 3/5 times 2/7, well, the first thing I should do is look for common factors to either cancel or cross-cancel, but there are none here, so I'll just multiply across and get the final answer, 6 over 35, 6/35. Well, what about if there are common factors? For example, 4/7 times 5/8. Well, again, I'm going to be a little bit more formal than we might be. I'm going to break each numerator and denominator into its prime factors. 4 is 2 times 2, and 5 is, of course, prime. Downstairs, I'll get 7. 7, that's prime, times 8 is 2 times 2 times 2. Well, the long and short of it is, once I've completely factorized these numerators and denominators, I can cancel out the common factors, and of course this reduces to 5 over 7 times 2 is 14. We're not always so formal when we multiply fractions. If I take 4/7 times 5/8, of course what I should do first here is cross cancel the 4 into the 8. 4 goes into 8 twice. Anytime you cross something out, there's an invisible factor of 1 that gets left. 1 times 5 in the numerator is 5, and 7 times 2 is 14. So a little more informally, we can cross-cancel common factors in a rational expression multiplication. Alright, let's do another example of multiplying rational expressions. Let's say I've got 25 over a cubed divided by 11 times b. And I'm going to multiply that rational expression by another rational expression, b over 5a. Alright, well, what I'm going to do is I'm not going to formally write out each prime factorization of each numerator and each denominator here. I can somewhat informally cross-cancel. 5 goes into 25 5 times. Well, a cubed over a reduces to 2 factors of a in the denominator. The b's will cross-cancel, of course, and I'm left with, let's see, 5 times a squared are the only remaining factors that are not 1 in the numerators, and 11 times 1 times 1 times 1 is, of course, 11. So my final completely simplified answer would be 5a squared, or 11. Alright, so what about when you've got polynomial sums and differences? Do an example of that. Alright, let's look at this rational expression multiplication problem. I'm going to want to factor first to cancel out the common factors. Right? So get used to that. We're going to need to factor each numerator and each denominator completely. Factor first in order to cancel, or in some cases, or cross-cancel common factors. Alright, so let me completely factor each numerator and each denominator. X squared minus 6x plus 9. That, of course, factors as x minus 3 times x minus 3. The denominator of the first rational expression is a monomial, so it's already factored. Times the numerator of the second rational expression is also a prime factor. Can't factor it any further. Downstairs in the second rational expression, I can factor out, of course, a 6, and I get 6 times x minus 3. Alright, now I can play the cancellation game. Now it's very important to keep good housekeeping here, because some of these expressions get kind of lengthy in this section, and it's easy to get lost if you don't show good housekeeping. The common factors of x minus 3 here, of course, I can cancel out. Let's see, 5 and 6 does not reduce, but 5 does go into 20 4 times. So I'll cross cancel the 5 into the 20, leaving a 4 in the first denominator. And let's see, what else can I cancel out here? Oh yes, the x squared, the x will cross cancel into the x squared. You'll have a factor of x here. Alright, so I think I've canceled out as much as I can. What are the remaining factors? Again, when you see a cancellation mark, there is a factor of 1 really left in its wake. So I can say in my numerator, all that's left is an x minus 3 times x, right? So I'll write that out. X times x minus 3. All the other factors have turned into somewhat invisible ones. And downstairs, everything's left. Everything's gone except the 6 times 4 is 24. So there's my final answer. X times x minus 3 over 24. And that's a fine answer. If you want to go ahead and multiply that numerator out to get x squared minus 3x over 24, that's fine too. Okay. Alright, let's try something a little more difficult. And this one's kind of a long-winded problem here, so let me warn us. I'll try and write smaller here. Multiply and simplify. Now, really, we're going to simplify first, then multiply, then see what happens. Again, it's kind of a long problem here, so let me try to copy this correctly. 6x squared plus 5xy minus 4y squared. Right? That looks like a polynomial that's going to be able to factor. Downstairs, 2x squared plus 5xy plus 3y squared. Again, that looks like it's going to break down. Times 8x squared plus 6xy minus 9y squared divided by 12x squared plus 7xy minus 12y squared. Alright, so we've got a rational expression times a rational expression, and they're all including polynomials of degree 2, right? Alright, factor first. Right? The idea is here is you want to factor each of the 4 polynomials into all its irreducible or prime factors, and then look to cancel out the common factors. Alright, I'll try and make it clear here. The numerator of the first rational expression, the first polynomial in the first rational expression, factors as 3x plus 4y times 2x minus y. Now, let me make sure that's clear. Things are going to get complicated pretty quickly here. 2x minus y. And the denominator of the first rational expression, that factors as 2x plus 3y times x plus y. Alright, now I'll move on to factor the second rational expression, both numerator and denominator, of course. 4x minus 3y times 2x plus 3y divided by, downstairs in the second rational expression, 3x plus 4y times 4x minus 3y. Alright, so I've factored each of the 4 polynomials as clearly as I could. Now I'm going to look for some common factors across this multiplication. Let's see, 4x minus 3y, that cancels out with 4x minus 3y, leaving factors of 1 in their wake. 2x plus 3y cancels out with this 2x plus 3y, so I can cross cancel those two factors. what's left? Well, let's see. 3x plus 4y will cancel out with this 3x plus 4y. And nothing else cancels, nothing else cross cancels, so I'm going to be left with the final expression 2x minus y divided by x plus y. Alright, so a pretty nasty looking rational expression product turns into something a great deal simpler once I factor and simplify. Oh, and please, again, don't cancel out these x's. This is a tragedy that happens sometimes. Students will get to the final answer, correct final answer, and then start hacking away like this. Let me put this with a big no. You can't cancel out the x's. You can't cancel out the y's. Please. You can only cancel out factors of a product, not terms of a sum. Okay? Alright. Alright, so we've done a couple of examples of multiplying rational expressions. Let's now try to divide rational expressions. Alright. Dividing rational expressions. Well, as we know from Chapter 1, how do we divide fractions? Well, fractions are also rational expressions, right? So, for example, if I take 2/3 and divide it by, let's say, 7/9, well, the old expression keep, change, flip, they used to call it invert and multiply. You invert your divisor fraction and multiply. And of course 3 cross cancels into 9 3 times. 3 times 2 is 6/7. Alright, so that's all. That's arithmetic review. To divide rational expressions, it's much the same, but of course we're going to be dealing with polynomials, not just numbers. Example: 6 over y cubed z squared. That is a rational expression. And if I divide it by another rational expression, 20 over yz cubed. Well, just like we do with fractions, we'll invert the second rational expression and turn it into a multiplication problem. 6 over y cubed z squared times yz cubed over 20. Alright, can't really factor these. These are monomials and already prime. What I can do is cross cancel. Well, let me try to make this as clear as I can here. Y will cancel out all but 2 y's in the denominator. Z squared in the denominator here will cancel out all but 1 z in the numerator. And 6 does not divide into 20, but 2 does. 2 goes into 6 3 times, and 2 goes into 20 10 times. So it looks a little complicated here, but I think you can see it. What are the remaining factors left in my numerator? Well, it's going to be a 3 times z, so I'll write 3z in my final answer in the numerator. And downstairs I've got 10, or y squared times 10, which of course I'll write as 10 times y squared. So there's my final answer, dividing these two rational expressions. Try another one. Divide and simplify b cubed minus 4b over x minus 1, and that indeed is an x, it's not a mistake, divided by b minus 2. Well, how do I invert that second expression when I see nothing in the denominator? Well, the implication here is when a denominator does not explicitly appear, the assumption is you've got a denominator of 1. We don't usually write it because it is redundant. Well, not in this case. I'm going to completely factor each numerator and denominator and not forget to invert that divisor rational expression and multiply. So I'm going to factor as much as I can. Alright, please notice that numerator factors as b times b plus 2 times b minus 2, right? Over x minus 1, and now I'm going to invert that divisor rational expression. Well, it's already factored, so I'll just write it as times 1 over b minus 2. So I really did two steps in one. I factored each polynomial, really only one was factorable, and inverted and multiplied by the divisor rational expression. Of course, the b minus 2's cancel out, and I'm left with, well, b times b plus 2 times 1, and I'm not going to write a redundant factor of 1, divided by x minus 1 times 1 is just x minus 1. So there's my final answer, and of course you could multiply out that numerator product if you like. Either of these answers is equivalent and correct. Okay? b squared plus 2b over x minus 1. Alright, the next one is pretty nasty. Let me show you what I'm talking about. I'm going to delete this screen and go to a new one. I'm going to have a nice fresh screen here, and I'll do my best to illustrate this next example. I'm going to have to write smaller here. Mixed operations. What does that mean? Mixed operations means you're both multiplying and dividing rational expressions. Okay? Multiplying and dividing rational expressions in the same problem. Alright, let me copy this down. X squared plus 2x minus 3 divided by 6x squared plus 5x plus 1. That is my first rational expression. I'm going to divide that by another rational expression, 2x squared minus 2 divided by 2x squared minus 5x minus 3. And I'm also then going to multiply by another rational expression. Now don't panic, you're going to get a lot of cancellations here if you factor correctly. Okay? Alright. Well, let's see, I've got a division and a multiplication going on here, and the order of operations says do multiplication or division, whichever comes first, left to right. So this division gets done first. Alright, so what I'm going to do is I'm going to factor and invert at the same time. You must invert and multiply. Alright, so this operation I'm going to change into a multiplication by inverting, and I'm going to factor each of these four polynomials in the first two rational expressions at the same time to save space here. So factoring the numerator of the first rational expression, I'll get x minus 1 times x plus 3. Factoring the denominator of the first rational expression, I'll get 3x plus 1 times 2x plus 1. Now I'm going to invert the divisor fraction in that second rational expression. I'm going to factor it at the same time. So numerator becomes denominator and denominator becomes numerator, and factoring at the same time, that denominator factors as 2x plus 1 times x minus 3, and upstairs becomes downstairs. I'll get 2 times, of course it turns into a difference of squares, x plus 1 times x minus 1. Alright, I'll worry about that operation in a minute, and I'm going to factor this third rational expression also. Notice I can factor out a 2, and then I can also factor the remaining trinomial as 3x minus 1 times x plus 1. Completely factoring, look for the GCF first, right? And downstairs I get x minus 3 times x plus 1. Alright, so I've done it as simply and as neatly as I can here. And now I'm going to start canceling and cross-canceling common factors. First thing I see is I can cancel the x plus 1's here, leaving factors of 1 in their wake. What else can I factor out here? Let's see, cancel out an x minus 3 and an x minus 3. Cross cancels. I'll get an x minus 1. Cancels out with this x minus 1. And what's left? I'll get a 2x plus 1 and a 2x plus 1 cross canceling there. What else can I cross cancel? Don't forget about the 2's. This factor of 2 will cross cancel. And I don't see anything else I can make a cancellation with. So I've got 2 factors left in my numerator and 2 prime factors left in my denominator. So my final answer is going to be x plus 3 times 3x minus 1 divided by 3x plus 1 3x plus 1 times x plus 1. Alright, and that's my completely simplified final answer. Again, multiplication is commutative and associative, so you can rearrange these products any way you like, but certainly would be equivalent to this correct answer. Alright, so again, the moral of the story is keep good housekeeping and factor precisely, and to take advantage of all the possible cancellations that you can. Let's see, one more here, we'll call it a day. Divide the following rational expressions, and of course simplify your final answer. Now this one looks nasty too, but as we'll see, there's a little trick here we're going to invoke. Make sure I copy this right. 3x squared minus 5xy plus 2y squared. Okay, it's a division. 2x squared plus xy minus 3y squared divided by 3x squared minus 5xy plus 2y squared. Alright, I attempted this problem and I started to factor each of the 4 polynomials until I noticed something. Do you notice anything about these 4 polynomials in these 2 rational expressions? Do you notice these denominators are identical? Well, that means if I invert and multiply, I can just cancel them out immediately. Let me show you. 2x squared plus 5x. I'm going to recopy it while inverting and multiplying by the second rational expression. Alright, so to turn this division into a multiplication, I've got to invert this divisor rational expression. And the reason I didn't factor first here is because I saw I could very easily cancel out the entire expressions. 3x squared minus 5xy plus 2y squared. Well, once you have identical expressions as factors in both numerator and denominator, I can cancel the whole thing out. Alright, so that saved me a considerable amount of work. Alright, now I'm going to go ahead and factor this expression and this expression and see if I can find any common factors. I'll have 2x plus 3y times x plus y as a factored form of my first numerator, divided by, let's see, 2x and x in the first slots. I'll get 2x plus 3y times x minus y. Yes, that works. And of course, I can now see a common factor of 2x plus 3y top over bottom. Alright, so I'm left with x plus y over x minus y. Alright, this is my final answer. No, you cannot cancel out the x's, you cannot cancel out the y's. Those are elements of a sum, not products of a factor. So this is your final answer, and a pretty nasty looking problem turns into a fairly easy one if you're observant. Alright, we'll call it a day for section 6.2, multiplying and dividing rational expressions.